Okay, hey guys, hope you had a great Thanksgiving. I'm going to miss being in class with you today, but we'll go ahead and make a video of what I would have presented to you. We're going to go over the lessons for this week, which are 51, 53, 54, and 55. I think two of them are probably new to you, two of them you've probably seen before, so hopefully this won't take too long, and we'll go ahead and get started. The first one is lesson 51. And here we're talking about square roots. And we're going to go ahead and look at this m. Square root of m times the square root of n is equal to the square root of m times n. I know that you know that. If these two numbers are both positive, then this number would be positive. If these are both negative, if one of these is negative, if m is negative and n is positive, then this is going to be a negative number under the radical sign. And then we're going to look at, I'm rewriting this 3 times and you'll see why in a moment. If m and n are both negative, then this gets written a different way. Okay, so this, if both m and n are positive, this is a positive m and a negative n, or the other way around. And this is if they're both negative. Here's what this looks like. For example, if the square root of 3 times the square root of 2 are multiplied by together, and those are both positive, we simply get the square root of 6. Okay? Now we're going to say, let's say if we have a square root of negative 3, which we'll talk about in a minute, because you're going to be like, how do we take a square root of a negative number? And I'll show you. The square root of negative 3 times the square root of 2, that becomes the square root of negative 6. The negative sign is underneath the square root sign. Here's where it's a little different. If they are both negative, the square root of negative 3 times the square root of negative 2, that gets written like this. This is going to be different. It's not the square root of 6. Instead, it's a negative times the square root of 6. Okay? That is going to look different because it looks like if you're following this pattern, this should be negative 3 times negative 2, which would be 6. Because they're a negative number and it's under the square root sign, we get into what are called imaginary numbers. And so then the rules change a little bit. And when I show you this imaginary number, this will make more sense. But for now, just keep these rules in mind. That if these are both positive, this is positive. If one of them is positive and one of them is negative, it doesn't matter which one, then the negative sign is underneath the square root sign. If they are both negative, this is the one that's strange, then the negative sign comes out here, and this is positive. You'll understand this when we go a little further, but I just wanted to make sure that you saw that. That is all on page, well, it's in chapter 51 of your books, in case you need to refer back to that. But I wanted to make sure I covered that in the video. Okay, so a long time ago, in the 18th century, there was a Swiss mathematician named, I've always thought it was pronounced Euler, but it's actually pronounced Euler. Okay, so this man, Euler, came up with something to represent the square roots of a negative number. So for example, if we have the square root of negative 4, that means that something times itself equals negative 4. Well, that can't be a real number. That can't be any number found on the real number line because, as you know, a negative times a negative is always a positive. So how can we get something that's a negative number? That's where we enter. These are all the real numbers. Real numbers are ones that we can plot on a number line. Imaginary numbers can't fit in there. We have to come up with an imaginary number to make this problem work. So this man named Euler came up with a number that he called I, and it's written like that. And he said that I equals the square root of negative 1. Well, obviously the square root of negative 1 can't be found anywhere on here because we can't think of a number that we know of on the real number line that multiplied by itself will give us a negative number. But we can use this imaginary number to do problems with real numbers. So that's why this man came up with this system. So what does this mean? Okay, so then the square root of negative 4 can be written as the square root of 4 times the square root of negative 1. That goes back to this thing that I just showed you. We have the square root of a negative number times the square root of a positive number. And we're going to be able to solve this then. So that is what negative 4 equals. Well, we know what the square root of 4 is. The square root of 4 is 2. The square root of negative 1, we don't know. It's an imaginary number, but we can rewrite it as I, like that. So then the square root of negative 4 becomes 2 times I. Does that make sense? So the square root of, say, negative 13 becomes the square root of 13 times the square root of negative 1, which equals the square root of 13 times I. Well, that's another way to write the square root of negative 13. We can get rid of the negative sign that's underneath the radical by using the notation Euler's notation, which is I. So this can lead us to what are called complex numbers. A complex number is just a number that has both a real part and an imaginary part. For example, 4 plus 5i. This is real. We can plot it on a number line. This is imaginary. We cannot. When we write complex numbers, it's generally written with the real part first and then the imaginary part second. You won't see it written in this way because we want to put the real one first. Okay, so it's not generally written like that. We can work with these complex numbers. We can add them. And that's actually pretty simple. So if we wanted to add 4 plus 6i plus 3i minus 2, we simply do the real numbers first. 4 minus 2 is 2. And then we add these just as if we were adding any other algebraic expression. We get 6i plus 3i, which just equals 9i. Pretty simple, right? That would be the answer. If we do, let's do another one. Let's say we have 4 minus 3i plus 6 minus 4i minus 2 minus 5i. Let's simplify that. This one, be very careful right here. We need to watch these signs when you do that. We have to distribute that negative sign to both of these. If you get the wrong answer when you do your corrections, go back and see if there was a sign thing that you missed. Okay? First of all, we're going to go ahead to solve this. We do all of the real numbers first. So we have 4 plus 6, which is 10, minus 2, which is 8. So the real numbers simplify to 8. Let's do the imaginary numbers. The imaginary numbers, we have negative 3i minus 4i, which is a negative 7i, minus a negative 5i. So we have a negative 7i minus a negative 5i. Remember, watch those signs. Negative 7 minus a negative 5 would be a negative 2. So this gives us 8 minus 2i. 8 and a negative 2i. So that would be our answer. So pretty simple, pretty straightforward when you add and subtract them. But what happens when we start to multiply them? It gets a little different. Okay, so let's say we have 2 times I minus 3 times I times I times I plus 2i minus 4 minus the square root of negative 4. And we want to simplify this whole equation. Okay, so how do we do that? Let's take a look first at what what I times I is. I times I, same thing as I squared, by the way, means a negative square root of the negative 1 times the square root of negative 1. And what does that equal? Well, anything like, for example, the square root of 2 times the square root of 2, that just equals 2. The square root of 111 times the square root of 111 just equals 111, and so on. So the square root of negative 1 times the square root of negative 1 just equals negative 1. So I squared, which is an imaginary number squared, actually turns into a real number, negative 1, because negative 1 can be found on our number line. So 2 times I squared is the same as 2 times negative 1. So 2 times negative 1 becomes negative 2. Okay, now let's do this 3 times I times I times I. The I times I, as we saw right here, is negative 1. So that becomes 3 times negative 1. And we still have an I right here. So that's 3 times negative 1, which is negative 3 times I. So we have a minus a negative 3i, which just means a plus 3i. Okay? The 2i is as simplified as it gets. The negative 4 is as simple as it gets. Now we have a minus the square root of negative 4. The square root of negative 4 is the same as the square root of 4 times the square root of negative 1. The square root of 4 is 2 times the square root of negative 1 is just I. So the square root of negative 4 becomes 2i. So we are subtracting a 2i. So this becomes minus 2i. Now it's just a matter of finding all the like terms and adding them together. The real numbers become negative 2 minus 4, which is negative 6. Okay? And then we have 3i plus 2i, which is 5i, minus 2i, which is 3i. So we have negative 6 plus 3i. And that's the answer. Okay? I want to show you one more of these, which would be 3 times I cubed plus 2 times I squared plus 7i plus 4 plus 2i to the 5th. What does that equal? 3i cubed means 3 times I, which means I times I is I squared. I squared is negative 1. The square root of negative 1 times the square root of negative 1, which just equals negative 1. So this becomes 3 times negative 1 times I, which is negative 3i. Now we have 2 times I squared. Remember, I squared is negative 1. So we have 2 times negative 1, which is a minus 2. So we have 2 plus a negative 2. 7i is as simple as you can get. 4 is as simple as you can get. Now we have 2 times I to the 5th. I to the 5th is I times I times I times I times I, which is the same thing as the square root of negative 1 multiplied by itself 5 times. These two multiplied by itself becomes negative 1. These two multiplied by themselves becomes negative 1. And this square root of 1, negative 1, sorry, is still left there. So negative 1 times negative 1 is 1 times the square root of negative 1, which is the same as I. So we have 1 times I, which is just I. So I to the 5th is simply I. You see how we got that? Because we have each one of these i's is the square root of negative 1. And when you multiply them together, it simplifies to just I. So we have 2 times I, which is 2i. Now we can add all the real numbers. A negative 2 plus 4 is 2. Negative 3i plus 7i is 4i. Plus 2i is 6i. So we have 2 plus 6i. And that's it.